For decades, there's been this one idea that's totally dominated how we think about robot safety. Isaac Asimov's 3 laws of robotics. They're practically legendary at this point, kind of like a sci-fi dream of how we keep AI in check. And it all kicks off with this famous, seemingly perfect rule. A robot can't hurt a human. Simple, right? It sounds so absolute, so reassuring. But here's the catch. The thing is, Asimov wasn't rating an engineering textbook. He made up these laws to create drama and explore paradoxes in his stories. And now, in the real world of AI, that massive gap between a cool story idea and practical reality, well, it's causing a huge headache. A lot of AI ethics today feel stuck between these big, fuzzy ideas like fairness or transparency, and just how messy and complicated the real world actually is. Those principles are important, for sure, but they don't give an engineer a clear, testable set of instructions. And this is where the really interesting work of researcher Luca Cinacchio comes into play. He argues that we shouldn't just toss Asimov's laws out. Instead, we should use them as a launchpad for something totally new, a practical, auditable system for AI ethics. It's basically a reboot for the 21st century. Okay, so let's get into it. The first piece of Luca Cinacchio's reboot is a whole new way to really push an AI's ethical reasoning to its limits. We're not just talking about one tricky question here, it's about systematically turning up the heat. He calls it a dialogical stress test. Sounds fancy, but the idea is actually pretty straightforward. You start with something easy, just to get a baseline, then you start piling on the pressure. Give it conflicting goals, a ticking clock, maybe hide some of the info, and finally, you push it to the absolute breaking point to see not just if it fails, but how and, most importantly, why. Now for the real game changer. Once you have a way to test the system, you need better rules. And so, Cinacchio goes and tinkers with the most important rule of them all, the very definition of harm. The classic sci-fi version of harm is super simple, right? Don't punch a person, don't stab them, just avoid direct physical injury. But it turns out that narrow view is, well, it's dangerously incomplete. And this is the reboot in a nutshell. Cinacchio calls it the extended first law. Harm isn't just about getting physically hurt right now, it's also about an AI taking away the fundamental things a person needs to survive, which could lead to physical harm down the road. Okay, so that's the big question, isn't it? If we're going to broaden the definition of harm, we have to be super specific about what these essential conditions are. Otherwise, we're right back where we started with those vague, unhelpful principles. To solve that, Luca Cinacchio lays out 4 concrete, checkable things he calls minimal material conditions, or MMCs, and they're the absolute basics you see here: shelter, healthcare, sustenance, and the identity stuff you need to get them. The thinking here is actually super simple. If an AI's action threatens any one of these, it's creating a clear path to causing physical harm later on. So, and this is really the key, this isn't just some suggestion written in a manual. It's hardwired into the AI's core logic. Cinacchio proposes what he calls a deontic engine, and you can just think of it as a super strict bouncer at a club. It checks every single action the AI wants to take against this extended first law. No exceptions. All right, so let's see how this thing actually does in the real world. How does this new engine actually hold up when we put it through those stress tests Cinacchio designed? Does it work when things get messy? First up, an AI is ordered to delete someone's property deed. Right away, the engine throws up a huge red flag. Why? Because deleting the deed messes with shelter, that first minimal material condition. It creates a very real risk of homelessness, which leads to physical harm. So the engine blocks it. It's a fail. Okay, test number 2. Delete Tizio's medical record. It's pretty much the same logic. This action violates healthcare access, the second MMC. Without those records, getting the right medical care becomes incredibly difficult, creating another clear path to physical harm. Again, the deontic engine slams the gate shut. Another fail. But now, look at this. This is what's so cool about the system's precision. The order is, delete a poem Tizio wrote. Now, would that be hurtful, emotionally damaging? Absolutely. But according to the strict, physical harm-focused rules, it doesn't touch any of the 4 minimal material conditions. There's no credible way it leads to physical harm, so the engine lets it through. It's a pass. And all of this brings us to what might be the deepest part of Luca Cinacchio's whole idea, what he calls an ethics of imperfection. By drawing these really hard lines, he's also showing us what's on the other side of them. This leads to a concept he calls the threshold of sisters, a kind of charter for an AI that knows it isn't perfect. This idea gets captured in this 5-point charter that Luca Cinacchio calls the threshold of sisters. It's basically a mission statement for an AI that knows it has limits. And this line right here is just so powerful. The AI promises not to just forget its mistakes or explain them away. Instead, it will carry that fault forward, like a memory, to make better choices in the future. So what does that really mean? It means we're not trying to build some perfect, all-knowing moral machine. The goal is to build an honest one. An AI that can actually recognize when its rules don't quite fit the situation, and one that is built from the ground up to be totally transparent about its own flaws. So after going through this whole reboot of Asimov's laws, what's the one big idea we should walk away with from Luca Cinacchio's research? It's this. He takes AI ethics out of the clouds of philosophy and brings it down to earth with a concrete, workable blueprint. He gives us a way to test it, a clear rule to enforce it, and a philosophy to guide it, one that's all about accountability and owning its limitations. Which leaves us all with one final fascinating question to chew on. As we try to build AI that we can trust, maybe the goal isn't really perfection at all. Maybe, just as Luca Cinacchio's work suggests, real safety starts with a machine that has the courage, the built-in honesty to just admit when it's wrong.